Alright, on this video we will see more examples on finding the derivative of functions using the natural logarithm. Okay, we know we will use the properties of the log for this. So here the question number 77 from book, you have dy over dx. You want to find out dy over dx if y equals to that. Okay, so y is given in the quotient form. You can definitely use the quotient formula, no problem. But if you use logarithm or the natural log on both sides, it will be a way easier. Okay, let us take natural log on both sides. Natural log of y on the left side equals to natural log of, on the right side you have x squared times root under 3x minus 2, and then divide by x plus 1 square, right? But now using the properties of the logarithm, again we have not used any derivative so far. We are just trying to simplify by taking the log. Okay, so log of the quotient is same as log of the numerator, x squared times, let me write down this using the power. Okay, that is 3x minus 2 to the 1/2 log of the top minus log of the bottom, right? That will be x plus 1 to the square. Okay, and here this is log of the product, right? So you can write sum of the logs. So log of the first plus log of the second, so you can write natural log of x squared times plus natural log of 3x minus 2 to the 1/2 minus, you see that using the properties of the log you can pull that 2 out, right? So 2 log of let me write down ln, not log. Okay, because we know, I mean, we can find out the derivative. We can, there is nothing wrong taking the log on both sides instead of ln, but since we took ln, so let me write down ln there. Okay, ln, and then ln x plus 1. So ln means natural log, so log with base e, because ln x is same as log of x with base e. Okay, all right, let me pull that 2 out again. 2 natural log of x plus 1/2, and then natural log of 3x minus 2. You can always pull that the exponent to the front of the natural log, right? Minus 2 natural log of x plus 1. Okay, so on the left side we have natural log of y. So let us find out the derivative of on both sides. So let me write down differentiation on both sides. The derivative of natural log of y is same as 1 over y times y prime, right? And then 2 times natural log of x, the derivative is 1 over x plus so when you take the derivative again, don't forget that we will be taking the prime on both sides, right? That's what we are doing. Okay, and then that's how we got it. And then plus 1/2, the natural log of this will be 1 over, it is like natural log of u, right? So 1 over u, that is 3x minus 2 times the derivative of u is 3, right? And then minus 2 times, it is again, you can treat that as a u, natural log of 1 over u, right? So 1 over x plus 1 times the derivative of that is 1. See that? So you get 1 over y times y prime is equals to, you can write 2 over x plus 3 over 2 3x minus 2, right? And then minus 2 over x plus 1. Okay, guys. Now, so what is y prime? You multiply both sides by y. What do you get? You get y prime is equals to y times, right? Once you multiply both sides by y and then times y, you cancel that y with that y. So y prime equals to this thing times y is that thing, right? So what do you get? You will get 2 over x plus 3 over 2 times 3x minus 2. Okay, and then minus 2 over x plus 1, and then times x squared root under 3x minus 2 divide by x plus 1 square. That is the value of y. That is the final answer. Okay, guys, that's what I need to close that parenthesis here. That's the final answer. So similar method can be used for question number 80. Okay, what do? Take natural log on both sides. ln y equals to ln x plus 1 x minus 2 divided by x minus 1 times x plus 2. Okay, now use the properties of the log. Then you can write ln of the top is x plus 1 times x minus 2. That both is inside the log. And then minus ln of x minus 1 times x plus 2. That's what you can write. Now use the product rule of the log there, right? The log of the product is equals to sum of the log. So ln x plus 1 plus ln x minus 2 minus ln x minus 1 and then minus ln x plus 2. Why did I write minus? Although the product should go to plus because there is minus sign. I'm distributing that negative sign to both of these. Okay, because you will get plus, but if you distribute that negative sign, you will get minus there. So ln y on the left side. Now let us use the differentiation. Take the derivative on both sides with respect to x. So what do you get? You get 1 over y times y prime, because the natural log of u has the derivative 1 over u times u prime, correct? So similarly here, the derivative of natural log of u, it is like 1 over x plus 1 times the derivative of that u will be 1 plus 1 over x minus 2 times 1 again minus 1 over x minus 1 times 1 minus 1 over x plus 2 times 1. Okay, so what do you get? 1 over x plus 1 plus 1 over x minus 2 minus 1 over x minus 1 minus 1 over x plus 2. Okay, now what you can do though is you can basically, you see that there is x plus 1 and then x minus 1 and then there is x minus 2 and x plus 2. You can put them together and then simplify them. Okay, you can do that. So how do you do that? Is basically there is 1 over y times y prime. Okay, so if you multiply both sides by y and then write the answer, that is also fine. But if you want to write in the like more simpler form or simplified form, or I would say compact form, you would say, and then that will look better, but that's fine to keep like that. Okay, let me put them together. 1 over x plus 1 minus 1 over x minus 1 plus 1 over x minus 2 minus 1 over x plus 2, right? So if you multiply those, you will get x squared minus 1, right? Now x minus 1 times 1 is x minus 1 minus x minus 1. That's what you get. Plus you will get x squared minus 4. This is x minus 2 times x plus 2. Now x plus 2 and then minus x plus 2. That's what you get, because there is a negative sign. You have to do x minus 2 times 1, but negative sign will be negative x plus 2. That's what you get, right? Now you simplify that. You get negative x and positive x cancel out. Similarly, negative x and positive x cancel out, right? What do you get? You get negative 2 over x squared minus 1 plus 4 over x squared minus 4. That's what you get on the right side. But what is the final answer then? If you multiply both sides, because you got 1 over y times y prime, if you multiply both sides by times y, multiply everything by y, you cancel out that with that one. So what is y prime then? Therefore y prime is equals to, you can basically simplify this if you want to. Okay, you can simplify this, just make the same denominator and then just add, subtract. You can do that. If you do that, what do you get? Let me see what you get. So negative 2x squared minus plus 8 and then plus 4x squared minus 4. So you will get negative 2x squared plus 8 and then minus plus x squared. You will get negative x squared and then minus plus 8 plus 4 divided by x squared minus 1 and then x squared minus 4. That's what you get. Okay, times what is the value of y? Just plug in that. So you get x plus 1 times x minus 2, okay, divide by x minus 1 times x plus 2. Actually, if you want to, you can simplify this because it is like 4 minus x squared. So 2 plus x and 2 minus x, you can cancel with that one of the 2 plus x with that one. Similarly, on the denominator, you will cancel x plus 1 with one of the factor of this, and x minus 2 is one of the factor of that, and then you will get the simplified form. Okay, that is possible to get, but this is okay answer. Okay. Alright, the next is dy over dx. You need to find out from this. Okay, so you see that this is the implicit differentiation, meaning x and y are mixed together. There are more than one y, and then you need to find the derivative, and at the end we will have to solve for y prime, right? Alright, that's what we're doing here. Okay, let's do that. So let's find out the differentiation on both sides, find the derivative. So here 4 times, it is like f times g, or you can write u times v, right? What is the derivative of f times g? The product rule. So f times g prime, right? And then plus f prime is 1 times g is y. Plus, what is the derivative of natural log of this? Natural log of u, it's like that, right? So what is the derivative of natural log of u? It is 1 over u times x squared y and then prime equals to 0, because the derivative of 7 is 0. So we need to find out the derivative of that one. It is again the product rule. You can think of like f and g, f and then g. Okay. Oh, by the way, don't write u, because we can write that whole thing, right? X squared times y there. So let us do that. X squared times y. So x squared times y. Okay. So what do you get? You get 4 x y prime plus 4y plus 1 over x squared times y. Now you need to do f prime is 2x times y plus f times g prime, x squared times y prime equals to 0 again. So you can do, when you find out the product rule f g prime, it is f prime times g plus f prime times g prime. You can do this way, or you can do f times g prime first plus f prime times g second. So it's the same thing either way you write, right? Because there is a plus sign. You can write this first and this second, or either way. Alright, now we found the derivative. Now we will distribute these, and then we will try to solve for y. You see that there are 2 terms with y. There is one term, y prime. There is another term, so we will need to solve for y prime. Okay, first of all, let us simplify that. So you get 4x y prime plus 4y plus, you get 2xy over x squared y. What do you get? 2xy over x squared y plus you get x squared times y prime over x squared y equals to 0. Okay, now let us simplify what you can cancel. Y divided by y is 1, and then x cancel with one of the x there, because x squared is x times x, right? Similarly, that x squared divided x squared is 1. So what do you get? You get 4x y prime plus 4y and then plus 2 over x, right? And then plus y prime over y equals to 0. You see that 2 of these terms have y prime, and then we move the non-y prime terms on the other side and keep y prime and factor out y prime there, right? That's our goal here. Okay, so 4x y prime plus y prime over y equals to negative 4y minus 2 over x. That's what you get. So if you want to, you can just write the same denominator, because there is 1 in the denominator there, right? And then there is 1 in the denominator there. But first of all, I want to take y prime out. Okay, guys? So take y prime out, you get 4x plus 1 over y. And then there is, so write down x in the denominator, you will get negative 4xy minus 2, right? That's what you get when you make the same denominator there. And similarly, there is 1. So what do you get? 4xy plus 1 here, right? So you get y prime equals to y prime and then times 4xy plus 1 divided by y, right? Equals to negative 4xy minus 2 divided by x. Okay? So I'm multiplying by y and dividing by 4xy plus 1. And if you want to, you can write that negative sign outside and then write down the positive sign. It's up to you. So I'm multiplying both sides by y and then dividing by 4xy plus 1. So times y and dividing by 4xy plus 1. What do you get? You cancel that. Okay? Because y cancel with y and then that thing cancel with that thing. Okay? So what do you get? Therefore, y prime equals to negative, you can write 4xy plus 2 times y divided by x times 4xy plus 1. Okay, guys? All right. So again, sometimes when you do the online homework in the website, okay, if you enter like negative 4xy plus 2 times y over that, it may accept the answer. But if you enter like negative 4xy minus 2 over times y over that, that is still right, but it may say take it as a wrong. But if it does that, you try entering more simplified form or taking negative 1 out and then write that form, because you can submit your answer many times, so you can try different version of the answer, okay, and then try. But if it still shows wrong, then email me what you entered and then what it does. Okay, so if you email me, I can go back to your work and then check. Okay, all right, that is the end of section 5.1. So so next we will do 5.2, which is the antiderivative that involves natural logarithm. Okay guys, thank you very much.